Hello everyone, welcome to AI Anytime channel. In this video, we are going to implement a RAG app, Retrieval Augmented Generation, for medical domain. And for this app, we are going to rely on a new large language model named BioMistral. So BioMistral, an LLM that has been released in the last couple of days, and it is a medical domain specific large language model having 7 billion weights parameters and has been outperforming a lot of other models even on the higher weights categories. And it's competing well with the likes of GPT 3.5 Turbo and the other closed source models providers. Now, of course, there's a caveat to that because these are all has been fine tuned for downstream task or a very narrower task like medical domain, for example. The other models that you see, they are general purpose model. So my recommendation is you stop comparing. Okay, you should stop comparing, these models with the bigger models. Bigger models will, of course, any day overtake all these models on complex use cases because they are general purpose model. But we'll see in this video a lot of things, right? I think you should watch this video completely. Of course, the code will be available on my GitHub repository, and if you don't want to listen to me, you can just go ahead and fork the repository and do whatever you want to do with the project. But if you stay with me in this video, you will learn a lot. And I'll tell you that how you should build a domain specific RAG. Now we are going to look at the medical data here. So I will tell you that, okay, how to select an embedding model. You should also select a domain specific embedding model. So we're going to rely on PubMed BERT in this video because BioMistral again has been trained on PubMed central data. So look at the combination. For embeddings, we're going to rely on PubMed BERT because the weights would have been like the weights assigned to vectors would have been better because it understands the medical nomenclature or medical grammars or taxonomy better for that embedding model. For LLM, we are relying on BioMistral again, which is a medical specific large language model. And we're going to use Llama.cpp because we are going to do this on CPU, as I said. So we're going to use Llama.cpp, LangChain, BioMistral, PubMed, BERT. These are the combination. And for the vector database, we are not going to rely on a store like Chroma or FAST. We are going to use a self-hosted vector database called Qdrant. Okay, so we will run it all locally, complete open source, not relying on any closed source or API provider, and we are going to build this application. So let me just give you a quick demo of that. So if you look at over here, let me just wear my glasses, by the way. I have some eyes power there. Okay, so now if you look at over here, we are calling it biomedical RAG app, and it has some about the app. It says this is RAG implementation using open source stack. BioMistral 7B has been used to build this app along with PubMed BERT as an embedding model, Qdrant as a self-hosted vector DB, and LangChain and Llama.cpp as an orchestration frameworks. Now, everything on premise, your infra, no, not paying anything, data is not going out, everything, private, everything. If you have confidential data, you are not giving it to third party, right? That's the real agenda of this video. And trust me, this is easy, guys. Okay, don't have, it's not rocket science, and I'll tell you that how you can do that. Now, let me ask the question. And you can see I'm asking, tell me about motor symptom management. And the question is coming from this particular document. So we have two documents. Let me just quickly show you the documents that we have. And this is inside my data folder. And you can see these are the two documents that I have. One is oncology, and the other is some data related to AIDS and HIV infection. Now imagine if you want to build, you know, a, a biomedical literature based chatbot where you want to retrieve information related to human health, some diseases, symptoms, and things like that, right? How you can build a chatbot for that. So that's the reason I picked these two documents. You can have 20 documents or n number of documents as well. Now I'm asking a question. Tell me about motor symptom management, and it says processing. Now what is happening over here? My Qdrant vector database is running inside a Docker container. So you can see it over here. This is what it's called, vector DB. It's running on localhost 6333 port. And you can see this is my vector DB. I'm looking at these are some chunks, and you can find out the info over here. You can see this is the info. We have around 542 vectors count for this particular vector database. This is all self-hosted. You can host it in similar way on Azure, AWS, or GCP, or wherever you want to host it. If you want to deploy this on hyperscalers or cloud, basically. Now, let's come back to our application. You can see it's processing on CPU. It takes around 30 seconds on average to fetch a response. First, it retrieves from vector DB using Qdrant, and then that relevant chunk is passed to an LLM to synthesize the response, so you can have a human-like response, right? Now, this is all happening. Let me just show you here. You can see it has entered into. We got our output, by the way. Let me just show you the output. If you look at the output, it says I'm asking a question. Tell me about motor symptom management. And it says motor symptoms are common in Parkinson's disease and can cause significant disability. The goals of motor symptom management are to improve quality of life by reducing disability and to prolong independence in activities of. So I got some response which is fantastic, and it also gives me the context. You can have a look at the context, and it also gives you the source document and from which document it has retrieved. You can see it's oncology PDF. This is the document that we have over here. This is the oncology PDF that you see now, and from here we are just retrieving it, and then LLM is doing its job to give you a synthesized response. You can see it over here. Now, this is one question. You can see that it took around 30 seconds, and if you have a better compute, it will be even more faster. We are not relying on C transformers. We're relying on Python Llama.cpp in this video, so it's easy to set up and you can use it on CPU as well. So here is the Qdrant, here is the app, and everything running inside locally. Here is our code, and I will show you that how you can build this application locally, and you can of course deploy it on some hyperscaler as well. So let's jump in and utilize BioMistral and some other open source stack to build this RAG application, guys. All right, so to build this application, first thing what we need is a model. And here is the BioMistral default model, the base model. Sorry, when I say default, base model. But we are going to rely on GGUF model, which is a quantized format of this particular foundational or base model, BioMistral 7B. In this case, BioMistral becomes the base model and the GGUF becomes a quantized model. Now, where can you find that? Okay, so to have less compute, and credit goes to Mazir Panahi. He is the creator. He created this quantized model. All credit goes to him to for creating this GGEWF model. So please, you can see it's already have been downloaded. Please give him some star and give the credit and shout out to him for quantizing the model and make it open source. Now, what I'm going to do here is I've downloaded this. This is what you have to do. This is the model you have to download. When you work with 4-bit quantize, the recommended model you should use is the KM model. So km.gguf, which is around 4.37 GB. You just have to click here and it will download locally. That's the first thing that you need. You need the model. The next thing that you need is an embedding model that will create vectors of your document or data that you have. For that, you can get it from here. Of course, don't worry, I will give all this link in description. So if you want to read more in detail, you can read there as well. Now, it's called PubMed BERT based embedding. And here is a catch, guys, right? I think this is important for you to understand. If you want to build domain specific RAG, for example, contract management, asset management, if you want to build something for underwriting, if you want to build something for, healthcare, you should look at model which are domain specific. Otherwise, go with GPT-4. Doesn't make any sense to just use a LLM, which is 7 billion parameter. GPT-4 has seen more, but there are a couple of regions we are not using these larger models. One, of course, sustainability. A lot of carbon emissions. If you work in enterprises, sustainability is a topmost priority. So you also have to look at some other alternatives, the models which are smaller in size. That's the one thing. The other thing is also the compute power. So GPT-4 is available through APIs, but when you use a lot of API calls, and you know how costly it can become. So if you can set up something locally or on premise, even on CPU, even the model is smaller, so you will basically reduce a lot of cost. And that's why these are the two primary reasons that we go with the smaller models when I say. And then the data protection privacy regulations comes in. We'll not talk about that. I have talked about it in a lot of my previous videos. Now, we're relying on PubMed BERT embeddings. Okay, we are going to use this through sentence transformers, and you can see it has been fine-tuned using sentence transformers. It says it maps sentences and paragraphs to a 768 dimensional space, dense vector space. So you can see it's 768. It has been on PubMed abstract pair. So it's fantastic because BioMistral is also has been trained on PubMed Central. So it's a great combination. So BioMistral and then PubMed BERT based embeddings, combining both because the data corpus is quite similar. Okay, for that. So now let's come over here on our ingest.py app.py requirements. You can see these are the requirements. This is, you don't have to be scared of this. I just did a pip freeze and these are the requirements you need. If you have a 16 GB of machine, you'll be able to use this without any problem. Okay, now the first thing that you're going to need is an ingest.py where we are ingesting the documents offline. For that, you need Qdrant because I'm relying on Qdrant. If you don't want to use Qdrant, feel free to use Viviate. If you want to use open source, feel free to use Milvus if you want to use open source. These are vector databases. If you want to use vector store, which is not scalable, you can't scale with that, then you can rely on ChromaDB, fast CPU, and things like that. That helps you basically do faster prototyping and proof of concept. Okay, so please be aware of that. So if you want to scale things, you need a self-hosted database, vector database. For that, Qdrant, Milvus, and Waviates are the recommended one. I'm talking about the open source. Closed source, Pinecone, of course, one of the most preferred one. These also provides, so Qdrant, Waviate, they also have cloud clusters, cloud services. You can also use them. And then you have a lot of hyperscalers, open search service by Amazon, AWS. You have GCP has its own LOIDB and things like that, right? So matching engine and whatnot. So feel free to use whatever you want to use. The concept is it will create some vectors and you have to store that vector somewhere. You use it in a store, use it in a database. It's your choice. Now, if you want to follow along, what I am doing, so I have used Qdrant. What you have to do, you need Docker install in your machine. You can see it's running on my machine. You can see this is how I have started. Let me show that. But first thing, if you have Docker install, if you don't have, if you are on Ubuntu machine, just do sudo install Docker, whatever. And if you are on Windows, you can just download or install Docker desktop. Now, once you have done that, just have to do Docker pull. You can see it's suggesting me, it's recommending because I have ran that command previously. It says docker pull qdrant slash qdrant. Once you run this command, it will download a image, docker image of qdrant, and that you have to run. After that, what you have to do? After that, you can just do docker images. Once you do Docker images, it will show you, you can see I have one image, which is called Qdrant. And if you want to find out if there is something already running inside a Docker container is something, which runs some kind of software packages. Now, if you look at here, it says you have to do Docker PS for that. So if you do Docker PS, it will show you all the containers. You can see one container, which is container ID, and Qdrant is running on this particular prompt. Sorry, particular port. Now, if you want to run Qdrant, this is how you have to do. To do Docker run, and you can run like this. Docker run -p 6333 and things like that. Now, if you want to go a bit deeper inside it, you can see this is where we have Qdrant documentation. I will give the link in description. Very easy to set up. Just have Docker install. That's it. Now, once that is running, you will be able to create vectors, and that will automatically get stored in that running container, which is a vector database. Now, let's jump in and write some code here. Now, the first thing that I'm going to do is embeddings. So embeddings, I'm going to rely on sentence transformers embedding, and here you pass the model name. So let me just pass my model underscore name, and my model name is nothing but the PubMed thingy. So let's get the PubMed thingy from here, copy it, come here and paste. And you can see this is the embeddings model that I'm not going to run this because I'm already running it, but I'll show you how you can do it. Now, you can see we are using unstructured file loader because you will have PDF, docs, and things like that, right? You can put all of these files inside a directory. So I have a data here, data folder, and in data folder I have two files. You can keep n number of files depending on what kind of compute you have, and you can have document, you can have PDFs and things like that. Now, for that, let me show you. So we have unstructured file loader and directory loader, two things coming from document loaders class. Then we have recursive character text splitter, and then couple of other things like sentence transformers, Qdrant, and things like that. Now, what I'm going to do next here is I'm going to copy something from here just to save some time. And I'll show you these are very common, right? So if you paste it over here, you can see I'm having a loader variable that uses directory loader class from LangChain, and then I'm passing my data path where I've kept all my data, and it says show progress true, so you'll find it out in terminal if those are being loaded. And then I'm giving a loader class, in loader class, I'm saying use unstructured file loader. If you want to use PyPDF, feel free to use PyPDF loader. If you want to use PyMoPDF, you can also use that. You can also use fits, whatever, right? So it's your choice. Unstructured is better because it has the ability to get tables, unstructured data and things like that in a better way. Now I'm just doing documents equals loader.load and then have a text splitter which says having a chunk size of 700 and chunk overlap of 70, keeping a smaller chunk size, but you can increase it and just to save some time quickly. And then have a printing text, but let me remove that. We don't need it. Now, once you have the text thingy done, you have to define an URL because you have to run the Docker inside a container. It's running on a port, and that is how you write it. So you do HTTP, and you can see not www. You have to do localhost, and then you have to do 6333. This URL is where your Qdrant is running. So if you don't understand how Qdrant works and what are the features, I have a dedicated video on Qdrant. I will give the link in description. Please refer to it. Now URL, and now next have a variable called Qdrant, and I'm gonna use Qdrant dot from documents, and here I'm just going to define a few parameters. Now first thing is my text, so I'm passing my text, which on top of that we're going to create the vectors. Now we're going to have embeddings, so let's have an embedding thingy, and then we have URL equals URL, and then we have prefer gRPC. I'll tell you because this is important. So I have covered that these things in detail. This helps you with remote connections. Basically it's a remote protocol that's been created by Google. Okay, so Google created gRPC many years back for remote connectivity, and because it's running on Docker and you might be using this component in some other network or some other service, how you can use gRPC to connect with that, right? So prefer gRPC, and then I say false for now. I don't want to do that. Now gRPC, and then you can give a collection name of whatever name you want to give it to your database. I'm going to give it like already has given. You can see vector db. That's it. Now we can use this Qdrant and just print it. So let's say print vector database created is created, things like that. Now once you run this, you just have to come here and run uh, inside this. I'm already running it here. You can see that I have a virtual environment in this directory, and now you just have to do python ingest.py. So once you do ingest.py, you have to wait for a few minutes up to few hours depending on how big your data is. If you have n numbers of files, like 100 of files, then it might take hours to create vector and store it in that in running container, the vector database, right? So I'm not running it because I had two files. I already created it, and you can see it's running on it's already running on. Apologies for the background noises, guys. You can adjust it for a while now. You can see it's running here on 6333 vector db, and you can see snapshots, visualize points, and things like that. All of it's running. You can see this is how it's running. Now this is done. In Once you do it, your vectors are created. Now let's move to app.py, where we're gonna have a fast API backed API endpoints, fast API app. So it's a fast API application. If you don't know what fast API is, it's a Python library to build scalable APIs, okay, in Python. Now you have to create different structure of format. One is you need a static folder, you need a templates folder. Inside a templates folder, I have an index.html. Now index.html is important. I closed my app because you were seeing that interface. For that, we have written some HTML bootstrap CSS code. I will give you this code. These are the code that I'll just this is already available. And just to tell you quickly a few things, we are using await fetch because we are using the fetch method, fetch technique in vanilla JavaScript. Okay, and we are using a post. You can see we are getting the form data from fast API and then just processing it to return the result. That's what we are doing on the front end, at least on the getting the result from fast API. Now app.py, and here I will show you that app.py what we are going to do. So I'll not write a lot of code because that code is already available on my previous videos and things. Right now, let's first initiate the app. So this is how we initiate a fast API app, and then we mount some also define the templates like Jinja 2 templates. So we are using Jinja 2 templates because we have been working on the UI, and Jinja 2 provides you to work with the HTML templates in fast API. Now you can define your directory, that where have you kept your uh, you can see for my case it's templates, the index.html. Now you can also mount it, so app.mount. So you can mount your static. In static, you can keep all your images, logos, and things like that. Now, static and static, I'm going to write static files, and static files, let's write directory, and my directory is nothing but the static. Now, after directory, you can also give a name. So the name is also static. Now we are done with the app initialization. Now you have to define your local LLM path. So you have to download it from that Hugging Face repository. I'll give you the link in description. Now you have to define. You can see in my case, it's here called BioMistral. So let me just write it. BioMistral 7b dot q4 underscore k underscore m and then give dot gguf, and this is how you define the local LLM path. If you are keeping it some other folder, you have to give the right path for that. Now, just to tell you, right, how are we loading the LLM and how we are going to inference it? We are using Llama.cpp Python. So Llama.cpp is a revolutionary tool, okay, that has been created for faster LLM inference, okay, and that's why we are using. You can see we are using here called Llama.cpp from LangChain community.llms. We have a prompt template, we have retrieval QA chain, and a few fast API thingy that I will explain a bit later. Now let's have an LLM variable, and here we are going to use llama cpp class. In that llama cpp, I'm going to define a few. So first is model name. My model name is nothing but the local LLM. After local LLM, I'm going to give a temperature. Temperature controls the randomness and creativity of a large language model. So for temperature, keep it lower for complex or regulatory or use cases which might be risky if the result is not appropriate. For content generation, email writing, and things like that, you might keep temperature a bit higher. Okay, for that because there's not much risk involved. Now temperature, I'm gonna keep it like 0.2. Okay, or let's keep it 0.1. This is my temperature. Now I'm going to have a max tokens. How many tokens I'm looking at, the max tokens. So let's keep it 2048. And then I'm going to have top P. You can have a lot of other inference parameter that you can keep it, but I'll just limit it over here. Now, if you want to get streaming tokens, you have to use callback handler. That option is also available in Llama CPP. You can go through LangChain documentation and you can find it out about the callback handler, through Llama CPP. Now, let's write print LLM initialized and things like that. Or yeah, LLM initialized. I'm just looking at it if that LLM has been initialized. Now we are done. Let's have a prompt template. So I've created a GitHub gist just because these are mundane tasks to do, right? Who will write prompt? But I'll tell you that few things. Okay. This is a prompt template. We are saying use the following pieces of information to answer the user's question. If you don't know the answer, just say that you don't know. Don't try to make up an answer. Context, question. You are passing the context which is coming from the retrieval, the vector database. Question is your question that you ask. And I'm saying only return the helpful answer. Answer must be detailed and well explained. So I just put a bit of instruction over there, and you should do that. Otherwise, it will give you a very less tokens. Now, prompt template is done. Let's have an embedding thingy. You're gonna rely on the same embeddings model. So sentence transformer, and you're going to write model name equals the same PubMed thingy. You can get it from here, ingest.py. So let's get that. Okay, from app.py, and here we go. So the model name is done, embeddings. Now our URLs, which is running here. So let's get that URL, because when you ask a question, the retriever algorithm goes to that retriever, okay, vector database, and connect on this port and fetches the right relevant chunks for you, so the LLM can make a synthesized response out of it. Now the next is client. So client equals, and I say, hey, look, you use Qdrant, and in Qdrant I'm going to use Qdrant client, by the way. So Qdrant client, and inside this I'm going to pass URL equals URL, and then you can do prefer gRPC, otherwise it might give you an error. So you have to do a fix of that. Now client is done. Now when client is done, you're going to have a DB variable. Now DB Qdrant, uh, let me think. You have imported Qdrant on here in line number 11. Yeah, this is fine. Now Qdrant, and here I'm going to pass my uh, template, no, not template, Qdrant, pass our client embeddings, and yes, so client equals client, and embeddings equals embeddings, and then you pass your input, not input variable, uh, client embeddings. What was our collection name? Let me just have a look. Collection name is vector db. Now you pass your collection name, so collection name equals vector underscore db, because you can have n number of vector databases, right? So you need to fetch the right vector db name, so that is my name. And then you write your prompt, so prompt equals prompt template, and then you pass your template equals prompt template, and then you write your input variable. So there are two input variables, input underscore variables, and these input variables are nothing but you have context and then you have question. So let's write the question. Prompt is ready. Now we need a retriever. So retriever equals underscore retriever, db.add underscore retriever, and then you're going to give search, excuse me, search underscore k works, right? So search how many top k documents you want to retrieve. So let's have a look at k equals kind of not k, let's have a look at that. K equals or not equals k colon, and I'll keep it 2. I need only 2 top documents, okay, for that. So retriever, our retriever is done. Now what I'm going to do is I'm going to copy a couple of endpoints which is coming from uh, my previous videos and GitHub repositories. You can find it out. Now I'll explain what we are doing. So we have first, which is basically the index.html, which is when you just go on localhost 8000, it will redirect you. I mean, it will direct you to that UI, the user interface. Now you have a get response function endpoint, and then you have a function. Function takes a query in a string format through a form, because we are passing this form data to JavaScript from the UI. Now we have a chain type quarks prompt. We have a retrieval QA chain. You are seeing, you can see LLM chain type stub, retriever, source document true, chain type quarks, verbose equal to true. So you can find it out, the logs and verbose in terminal. Then we have a response, blah, blah, blah. Answer source document response data, and we are using JSON-able encoder to return the result. That's it. That's what we are doing. Now we have written our code, guys. Now let's run it and see if we are able to get the right results, or if it's working fine or not. Let me open this here, and now let's again run uvcon app colon app, and once I run it, it will take a few seconds, and now we can come over here. Let me close all of this now. We don't need that. Okay, we don't need, let me just close this, close this, close this, close this. The thing that is running is our vector database. You can see it's a self-hosted vector database, Qdrant, running inside a Docker container on port 6333. Now here I'm going to open localhost 8000. Once you do localhost 8000, it will open this app called biomedical rag app. Right now there is no memory inside it, but I think that is the challenge. You should take it and you should implement a memory inside it, chat memory, and you can build it as a chat bot. Now we have about this app, and here we are asking type your query. Now let's have a look at the document, guys. We have 2 documents. Let me just scroll down and let's see what kind of questions we can ask. I'm just looking at it. Okay, let me ask this question: what the HIV antibody test can tell you? Okay, and once I ask this question, once I said submit, now what I'm expecting is that here is the question that I have asked about HIV, and there's a lot of information here. Now, so first thing that will happen is once you ask the question, the vectors are being created for that particular question that you have asked. That vector goes to that vector database and tries to find out similar vectors in an n-dimensional space, and then retrieved some relevant vectors, basically the chunks, and then that chunk is passed to a large language model. So large language model takes that messy and dirty chunks, and then it synthesizes and create a beautiful response for you. That's what it does. Now let's have a look at terminal. What's happening? You can see it says entering new retrieval QA chain. So the LLM has the system has entered into a retrieval QA chain through lang chain, and it takes a bit of 30 to 35 seconds, 40 seconds to fetch you the response, because we are on a CPU machine. But if you have a GPU, you can do it on GPU. But most of you ask me that, hey, I don't have a GPU, how can I do that? Now if you look at over here, we got an answer. It says HIV screening test you know, sometimes give false positive readings, especially in populations where HIV is not present in high numbers, which is why confirmatory testing is always done on positive screening test results. This confirmation is needed to rule out false positives. Fantastic answer, because if you look at the context, it says what the HIV antibody test can tell you, and from this where it's getting the response, and you can find out this is the document that we have. You can see the what the HIV can tell you. The same thing from here, the context has been also printed. We are also showing context, guys, because it's very important. You have to show the traceability. You have to explain that from where the answer has been generated or retrieved, right? I think that is very important. So you can, because anyway you can't explain a large language model right now, but at least you can explain that how it has retrieved through context. Now this is the source document we are previewing, sorry, publishing or printing, but you can preview this. You can have a right hand side here something, a PDF preview or a file preview, and you can also make it even far better. Now let's ask one more question and see that as well. Probably I'll ask it from somewhere here, and let's see that. Okay, mm, what question should I ask? Okay. Let me ask this: the main categories of cancer, tell me the main categories. I'm asking this question now. Main category of cancer, and it says processing, and it will again go into a retrieval QA chain. You can see llama generate prefix match hit and things like that. Right, let's wait for it. And you can see this is where our vector database is. Now this is the vector database that we have, and here we are running our app, and you can see this is the document, and I'm expecting that it will tell me about sarcoma, leukemia, sarcoma, lymphoma, myeloma, and these are all different types of cancers. By the it's a very dangerous disease, deadly disease, and you guys should take care of yourself of that. Now let's go back here, and let's go inside the terminal and see. So you can see it has entered into a retrieval QA chain, and we are using Llama.cpp. You can see that logs in the terminal as well. It takes a bit of time to generate the result, but I think on CPU I think it's fine, right? You can do that. If you want a faster uh, system to build, I think you should look at Grok. Grok is fantastic. Grok chat, I have created some YouTube shorts on that. Look at the shorts section on my channel, you'll find about Grok. Now you can see it says cancer is a group of disease characterized by abnormal cell growth with the potential to invade other normal cells of the body. There are many different types of cancer, and they can be grouped into several main categories. These categories. So the max new tokens, I think we have to increase the max new tokens because it does not complete the tokens, right? So that's it. But I think it gets it. But the retriever doesn't seems to be retrieving it, because most probably because they are only printing the, if you look at here, we had k equals to 2, but we're only looking at the first one. So that might be the reason we are not looking at it over here. But yeah, it does not complete the answer. Let's, so yeah, this is fine. I think now you can also test it out and let me know your feedback, thoughts. What do you think of BioMistral model? Because BioMistral has been creating a lot of noise, and I will recommend that don't fall into this trap and noise, right? Keep solving problem, and these are all risky technology, and see what is the best way of building a chatbot, or to implement some solutions for you. Now this entire project will be available on my GitHub repository. I will give the link in description, so you can go and take that and do whatever you want to do with that. And if you have any thoughts, feedbacks, concerns, or any issues, please let me know in the comment box. You can also reach out to me through my social media channels. You can find those information on channel banner and channel about us. If you like the content, please hit the like icon. And if you like the content I have been creating, and if you haven't subscribed the channel yet, please do subscribe the channel. Share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.